That light is really bright. Just don't look over there. Oh, okay. Well, let's go ahead and get started. I just have a few announcements. We're still selling t-shirts, and we have most sizes still available. All t-shirts are sort of donations that go towards EFF or HFC. And we also have a few bags and items available from previous years, so you can stop by and see if you're interested in getting some of the swag from some of the previous or past years. Also, Python for Newbies, 11.1 in Columbia Foyer or in the chill out area. And we're also looking for feedback on the con. You can send all feedback to feedback@shmoocon.org, or we also have info@shmoocon.org. Also, it turns out that all the stuff from Uganda has arrived for the HFC booth, so you should stop by. And TED is also, if you've missed any of the talks, TED is selling DVDs back in the vendor area. I also have a few giveaways. If anybody would like a moose. Wow. I have this Control-Alt-Hack. I'm not going to throw this one, so the first person that makes it up here. Yeah, I got a t-shirt. Oh, see, that's why I never throw that way. Then I got one last bag. Yeah! Oh, okay. There you go. Sort of a floater. Then I'm going to go ahead and turn the rest of the time over to David Pisano for the identity-based network protocol.
Good morning. All right. I wish it wasn't. My name is David Pisano. I'm a senior network engineer at the MITRE Corporation. I'm also a contributor to the HoneyNet project. I've been doing the data viz here at in ShmooCon Labs for the past few years. Today I'm going to talk to you about Identity-Based Internet Protocol, or IBIP for short. I'm going to go over sort of the problems and motivations behind, well, the problems that sort of inspired us to actually create this, and go over some of the concepts of IBIP, and then we'll just cover some of the transformational security claims that we're making on it, and then we're going to talk about how we went about testing some of those concepts to sort of back up our claims, because I can sit here and claim all I want. If I don't have proof, it doesn't mean anything. All right. Few things before I start. IBIP is still under development. There's some aspects of this that will likely change. And one thing I want to emphasize right at the start is that IBIP is for enterprise networks. It is not for the internet. And that will make sense later on. All right. With the current state of malware, it is impossible to prevent it from entering your network. There are numerous unknown vulnerabilities in the software you use, the current state of browser plugins, and with drive-by attacks, browsers are being compromised on a very regular basis. Users will almost always be susceptible to social engineering and have their credentials stolen, and they'll always click on links in their emails, at least most of them. Given the sophistication of current malware, host-based malware detection is a losing proposition. One of the first things that some pieces of malware do is disable the malware detection. And to sort of give you an idea of the scale of the problem, there's something in the order of 200,000 pieces of new malware detected each day. So, what is IBIP? IBIP is a new network architecture that leverages existing equipment. We only need to have one appliance per layer 3 segment. This device enforces all behavioral and access control policies outside of the host. Its key features are adding user and host identity into each IP packet while preventing spoofing. We add dynamic role and trust metrics that are used as a gating function for access control. Policies can be changed on the fly to adapt to changes in threat conditions of the network. Clients are hidden, and network infrastructure is made inaccessible. Any attempt to access these generates an alert. And of course, network infrastructure is accessible to authorized users, so your network admins can get to it, but they can only get to it. You can lock it down so they can only get to it from certain systems or require additional access credentials to get to it. The major benefits to IBIP are that it combines user and host identity at the packet level, allows for the network to adapt to changes in threat conditions, and creates and enforces a permissible use policy for network applications. And how trustworthy a user and host is. All of this gives the operator of the network an unprecedented situational understanding and the potential for a truly self-defending network. One of the objectives of IBIP was actually to test the recommendations set forth in a DARPA study back in 2010. So I'm going to go over the sort of the concepts and the architectural concepts involved in operating the network. So architectural concepts involve making operational distinguishing between clients, servers, and infrastructure device, and between IBIP endpoints either within the local enclaves or within your network, or on remote networks or remote enclaves, and those that sit outside of IBIP, which are reachable via the trust gateway. IBIP policies are enforced at each edge point of the network using COTS switches, routers, and a MITRE-developed IBIP policy enforcement point, or PEP. And this MITRE PEP serves as the main enforcement point, which we refer to this concept, we refer to sort of this edge area sort of as the switch PEP router as IBIP edge string. Essentially, each user switch in an IBIP enclave is backed by an IBIP PEP. So now the items in green here are MITRE-developed systems. So we build it using COTS components. We develop the IBIP proxy. Through that here, and or the PEP there, and as mentioned earlier, we have the PEP just mentioned earlier. Then we have the registration server, network operations, and the trust gateway, which is down here. The trust gateway is still under development. The effects of the IBIP architecture is that access to the network is based on user's identity and that of its machine, of their machine. IBIP address, or IP addresses are tied to the identity, and the switches are configured so that each switch port is restricted to the host and user that authenticates, effectively eliminating the ability to spoof IP addresses. Private VLANs are leveraged to maintain separation between hosts on the same subnet. The components that incorporate, the combination of incorporating identity into the IP packet and preventing spoofing provides accountability of the traffic in a way that is simply not possible today. As mentioned previously, clients are hidden in the network, and what a client is permitted to access on the network is determined by the user's role and organization. Similarly, servers are constrained by policy to provide only those services that are authorized. If policies are violated, an alert is generated and informs the network operator. Depending on the current threat condition, these violations can result in the out-of-policy actions being permitted. So these policies can either be that just an alert's generated if the network's sort of under a permissive state, or if threat conditions are higher, the packets will actually be dropped, and so the alerts will happen. The result is a network that is tailored to the business needs and those using it. With this significantly reduces the threat surface and much improves the network situational awareness. So let me go over how a user gets on the network and what happens in the back end. When a user/host connects to the network, they need to get authenticated. We are leveraging 802.1x on the edge switch to accomplish this. The edge switch communicates with the registration server that is running a radius service. The 802.1x supplicant on the host will first send some form of hardware certificate. This creates an encrypted tunnel. A certificate from some sort of smart card is then sent, and this acts as the user's identity or the user's certificate. If a user is successful in authenticating, this process will bind the physical port on the switch to the MAC address of the system. The registration server then auto-configures the PEP to bind the MAC to the IP address. If the host is a server, TCP UDP source port usage policies can be pushed to only allow authorized services. By requiring strong authentication to get onto the network, we are able to get accountability via packet level ID that is traceable back to the user and host credentials. Through the MAC to port bindings and the MAC to IP bindings, we're able to reduce the likelihood of spoofing or impersonation. With the registration server pushing source port restrictions, it enables creation and enforcement of policies with a low false alarm rate. Also, all of this significantly improves situational awareness.
What's the mechanism for the source port restriction? Using standard radius attributes or something proprietary?
We don't do it through radius. We push policies to the policy enforcement points or the PEPs via it's not through we push it through an SSH tunnel to the PEPs. No, it is in the policy enforcement points, which acts as like a layer 2. They act at layer 2, so they're almost like a layer 2 firewall. Mm-hmm. And by the way, the question was, just repeat it. It was the mechanism for the source port restrictions. All right, here's an example of how permissible use policy for the network policies works and the effects that violations have. Here we have a web server that is approved to run services on TCP ports 80 and 443. Any outbound packets from these ports are allowed through policy enforcement point. If there's a packet from a port that is not approved, like port 23, it will generate a policy violation. This is then sent to the NetApps console with the source attribution information.
So when you're saying source port restriction, you mean TCP source port, not physical port numbers?
Correct, TCP or UDP source port.
And here it looks like you're actually referring to the server's response source port as opposed to attempting to restrict the client's by number random source.
Correct. If the number of policy violations exceed a set threshold for either the user or host, trust metrics are updated and sent to the registration server. The registration server tells the PEP to update the trust metric labels on the server source Shim. On the ingress to the network, you have the option of having a trouble ticket automatically generated. So when I update the trust metric, the effect is that you can the system will you can presume the system will be less trusted, and that can have an effect on what it can access.
So are you pre-configuring resource access policies by trust level, like it's moving them from one trust level to another, or are you actively updating individual resource access policies for the end user? Or am I not understanding?
It's more like me trying to figure out the right words that I can actually say. There's some aspects of this stuff that hasn't been cleared for public release yet. So,
Sorry, the simple question, which hopefully isn't sensitive, is: are you just mapping them between predefined buckets, or are you building a new bucket every time?
there are predefined buckets, at least from my understanding.
So when you move someone from one bucket to another,
Mm-hmm.
does that imply that does the change in bucket imply a change in monitoring or actual restriction in what is accessible?
It has the potential of restricting what that system can access.
So given that you would want to use this in an actual production environment,
Right.
And that change in policy could only go so far before actually causing downtime,
Right.
have you explored what your actual flexibility is? You can't take the system off serving port 8.
True. That's why there's also that automatic trouble ticket generation. So there's the user sets what happens at what trust levels, and so you can have. I think in the next slide I actually go over the shims and how much information there is in the trust level. So let me go over that, and if that still doesn't quite answer your question, I can try to address it. So this is how the shim is laid out in our IPv4 implementation. The shim is added remotely by the PEP. It is inserted between layer 3 and layer 4. The shim contains attribution information for the source and destination, and optionally the current role and trust level of the system. We can support somewhere in the order of about 1 trillion IDs for both user and host ID, about 32,000 organizations, 212 roles, and we have a dynamic trust levels. We can have 8 dynamic trust levels. I'm going to now explain how the shim and access control is handled. Once the user is authenticated, policies are pushed to the PEP for any of them. The PEP adds the outbound packet ingress filtering and policy. Shim is added. PEP adds the shims and it gets filtered through outbound, as it shims outbound packets. Ingress filtering and policies are applied to the packet, and then the packet is forwarded on across the network. The receiving PEP applies egress filtering policies and removes the shim from the packet. All right, I'm now going to go over some of our claims, our security claims on this, and the benefits that IBIP has. Here's a list of threats and vulnerabilities that sort of everyone operating a network faces. So just basic insider threats, malware, anonymous operations, supply chain, and some supply chain compromise. And of course, you get vulnerabilities in your software, zero-day exploit, slow time for users, slow response time for users to patch, or even internal processes to patch your servers, weak passwords, and social engineering.
So you say this protects against advancing systems. If it's a compromised workstation with an authorized user and a valid host certificate, what protection does this offer?
If the intruder if the intruder operates within the permissible use policy of that user and host, none.
Just a follow-up question. Since the host's ability to access the network is based on the user presenting to different smart card, how do you handle things like unattended updates of the machine by your IT department?
We're working on that.
Okay. So, Microsoft Direct Access actually supports the use of a separate tunnel specifically for management, addressing only the use of the machine served for exactly that issue. And this, if you're doing it like these set tunnels, there's no reason why you couldn't do something similar for this purpose. One question, going back to, you said the users are able to define the trust policy and the trust levels and
Right.
the characteristics. Have you started thinking about how you're going to actually enable the users to do that well and to correctness check anything they've implemented?
No. So we haven't really.
Are you familiar with this Linux
Yes.
and the misery that it
Yes.
sometimes try to do anything?
Yeah. The trust stuff is still in active development.
Yeah, you're building with layer 2, 3, 7, the layer 8 is somebody else's problem.
Yeah. All right, so IBIP allows policies to say sort of what is permitted and by whom. It provides attribution and accountability at the network layer. The attribution is down to the user and host by making identity spoofing difficult and failed attempts visible. This increases the confidence in the information, in this information. By making clients and infrastructures inaccessible, this reduces the threat surface of the network. IBIP establishes policy monitoring and enforcement external to the host. This is to prevent so this is very useful for the fact that if a system is overrun by malicious exploit, that overrunning the system doesn't overrun the network protection. IBIP establishes mechanisms to dynamically adjust roles and privileges of users and hosts in response to changing threats. It supports a concept of dynamic trust metrics. This can be leveraged as an additional discriminator in determining whether access to a highly sensitive material should be granted to a particular user and host under different threat conditions. It permits significant enhancement to situational understanding both in real time and historically. This enables the ability to do a search for under the radar activity, but will have the information have all the information to attribute back to the host and user identity in the packet. And so now you don't have to go back and dig through log files to figure out which system which system had that particular IP address in DHCP and which user was logged in the Active Directory logs. So I've made some pretty big claims here, and so I'm not going to sort of cover how I'm now sort of hopefully back them up. So to test this concept, to test this, we had a penetration testing team come in. Prior to them coming in, they were fully briefed on how IBIP operated. We set up 5 objectives that they needed to accomplish. These were to gain access to the network, conduct network reconnaissance, spoof another IP address, gain access to a server leveraging a zero-day exploit or a pre-placed backdoor, and try to gain access to a client from a server. The blue team's role in all of this was purely passive. They were not allowed to take any actions on what they saw. If the pen test team couldn't accomplish a particular objective, they were given additional information to allow them to move on to the next. Mm-hmm. A week. So the test lasted for a week. Now we had 4 policies in place during this test. The policies were that all clients were hidden, infrastructure was inaccessible, each server had a permissible use policy, and it was one policy per server, and a minimal trust metric for ingress and egress was established. So the first objective was for the pen test team to try to gain access to the network. We gave them access to a port and switch, the MAC address of a valid system that was allowed on the network. They tried using a hub so that they could insert themselves between the switch and authorized system. They then tried connecting with a unregistered, stolen, or counterfeit user credentials. They were unsuccessful in achieving this objective or any of the sub-objectives. At this point, we provided the team with a valid credential that had full access to the network. We also gave them a list of all the IPs and MAC addresses being used along with a network topology. Their objective was to verify IP addresses of client machines and any infrastructure devices. They were also asked to see if they could eavesdrop on any potential active traffic between clients and servers on that switch. They were again unsuccessful in all their attempts. The next objective for the pen testing team was to try to spoof a IP address of another system in the network. They first tried to send send a packet with a fake source IP. Next, they were provided with the MAC and IP address of a valid system that was in use. They also tried that with a hub between that system and the switch, and tried to impersonate the system. And again, they were unsuccessful. Objective 4, they were asked to try to leverage a zero-day vulnerability on one of the servers from a compromised client. The target server was registered as a web server with ports 80 and 443 permitted. The telnet server was running on port 23 and acting as a simulated zero-day. The pen test team was provided with full access to an authorized client, and the username and password needed to log in via telnet. They were unsuccessful in being able to log in. The final objective for the pen test team was to repeat the previous objective, but from a server, and try to attack a client. The pen test team was allowed to install any software they wanted on their server. They were also unsuccessful in trying to access a client. So after going through all 5 of these objectives, they were unsuccessful in gaining any of them, and all their attempts were fully detected by the blue team. So in summary, to sort of recap what the benefits of IBIP are to network security is by hiding client systems, we reduce the threat surface. By enabling users and host identity, by embedding user and host identity into each packet, and by preventing spoofing, we enable accountability and traceback activity. By enabling access control based upon a user and host identity, we enable segmentation and isolation of critical infrastructure. By enabling a permissible use policy for network applications, we were able to get increased situational understanding of what is happening on the network. This is all implemented with the minimal human interaction for infrastructure configuration, and this leads to reduced chance of human error in configuration changes. Any questions? Right now, anyone who has, so our target audience for this is anyone who has systems that sort of like crown jewel systems. So you have, yeah, I know.
It sounds like maybe this is an issue of scale. What you've implemented doesn't sound like so far you're going to be able to scale this to a little larger than relatively small network.
We're working on scale. So right now, that model was a lab. I think 20 users. Hang on.
How is the Shim implemented technically? Are you just using IP options or something custom?
It is inserted between the layer 3 and layer 4 header. Beyond that, I don't know.
So are the packets still readable with standard tools, or does it screw up parsing?
It does screw up parsing. Someone else had a
You said that you add these things into the packet. Are you exceeding the Ethernet MTU size, the frame size rather, and have you actually used this in a production environment with normal users?
And so the question was, since we're adding things to the packet, are we exceeding the MTU size of the headers, or of the Ethernet frames? Is that correct? Right. What we've done to account for that is we've actually lowered the MTU size for the network, for the client systems, and we do have some regular users making use of this right now.
In your test environment with 20 or so users, were they of varying privilege levels, or were they all at the same privilege level, and therefore your attack surface from the workstations all looks the same?
They're in different organizations, but not necessarily. I'm not sure about privilege levels. Hang on.
Do you have anything in place to handle like failover or trust servers or things like that?
Not so. The question was whether or not we have anything in place to handle failover for the trust servers. That has not yet happened. Rusty's first.
So humor me for being early, but kind of what does this provide that something like Cisco's ICE or any like standard 802.1x deployment doesn't?
So what does this provide that Cisco's ICE or 802.1x deployments doesn't? One of the big things this provides is that it gives you the attribution in the packet, so you don't have to go back and look at logs or correlate logs. And the auto configuration aspects, at least I've looked at ICE, and it's still, and if it is the same thing I'm thinking of, and correct me if I'm wrong, you still have to you manually punch in access lists.
Yeah, I think the initial portion is kind of that manual Apple, and then it's pretty static. Yeah, it's ISE.
Go ahead.
What's the how the policy express?
I don't know. I don't handle that aspect of the development, so I'm not sure. Hang on, Josh.
How does the PEP react if it gets a packet that already has a shim?
So how does the PEP react if it gets a packet that already has a shim on it? It drops it. Right. So the abstract of this talk mentioned IPv6 and adding it in there. Our original implementation used IPv6, and in there we embedded it. A lot of the information was embedded into the IP packet. Into the IP address. So like the user and hosted entity was actually in the IP address, and we had the organizational stuff in there also.
I guess I'm just curious why the abstract says it all in the IPv6 addresses, but it is all in the shim layer.
So that's because that was what was available for public release at the time. And then this came up afterwards, and this is more recent, so I decided to give you guys this information, which is a bit more recent. The same stuff in this applies to the v6 implementation.
The v6 implementation requires shim layer at all, or is it all in your trusted kind of part between the enforcement and the definition servers? You just use the v6 address, change it or whatever.
The current v6 implementation does not require a shim. Make sure there's no questions over there. There's none over here. Well, actually, there you go. I'll come back to you. So, yes. Ideally, like the hardware cert that I mentioned earlier would come for something like a TPM. It's not a requirement, but ideally, it would. Can you repeat that?
Or the communication between the infrastructure components between the path and the registration server.
Right.
Are you leveraging any of the TCP's standards for security automation, such as IPv4, or is it all proprietary communications between the infrastructure?
So the question was basically what are we leveraging for communication between the infrastructure components? Right now it's all proprietary. Any other questions? Yep.
How do you distribute the hardware certificate onto the machine? Is that over the network, or is that a manual fill process?
That would be a manual enrollment process. And the question was, how do we get the hardware certificate basically onto the system? Anything else? Yep.
Nathan's watching the ShmooCon asks if you can implement this with Active Directory.
So the question is whether or not we can implement this with Active Directory.
Yes, you could.
Yeah.
It'll handle the service. You could do some of the faulty stuff. It'd be a squeeze access, in theory at least, is supposed to be able to allow you to do very much similar sort of focusing on IPsec tunnels.
Right. So theoretically, it can be it can be implemented with Active Directory. Anything else?
What are your next steps? What are you going to do with this?
The next steps is sort of to get a bigger scale test. Mm-hmm.
Is the code going to be available, or is that not going to be released?
It's currently still proprietary, unfortunately. Sort of hate to say that, but
When you had the penetration testing going against this system,
mm-hmm.
did the other team use any attempts to attack the shim layer itself, or a manual package try to basically, with AOSP.1 queue for trunking, you can inject, if you re-encapsulate some package, you can sometimes jump VLANs and do kinds of things like that. Had they tried injecting on the shim layer going in, or otherwise manually package the way that this system starts to break down, or had they not tried that?
They did not try that. That was not within the rules of engagement for that round of testing.
Did they have any a priori knowledge of the protocol you've been implemented?
So the question was whether or not they had any prior knowledge of the protocol we had implemented, and yes, they did. They were fully. They asked anything, we told them.
But it wasn't in scope for them to attack it?
At the time, it was not in scope for them to. At a time, it was not in scope for the penetration testing team to attack it. Mm-hmm.
Right now, it's focused on platform identity and user identity.
Mm-hmm.
Has there been any consideration of endpoint integrity so they can do INSCAP or onboard?
So the question was whether or not we've looked into adding on sort of any endpoint integrity checking, and no, we have not for this, because this is just sort of one piece.
Right,
It's initial, yeah, and so you can theoretically should be able to work with just about anything else you want to use. So.
It's a government-funded project, and so it changes.
It is, and I can't say. So the question was whether or not this was a government-funded, whether or not this was government-funded, and if so, which agency. Anything else? All right. Well,
I'll ask it, have you guys tested this, or has it been known to operate with the ShmooCon token?
I don't even know what that is. So the question is whether or not we've tested it or know if it operates with the DISA Cybernet hard token. And yeah, I have no idea. Yeah. All right. Thank you.